Hi there, welcome to another episode of Isabel Explains, and in this video we're going to be talking about how to solve and graph quadratic equations. Now first, let me clarify. Normally we are used to seeing quadratic equations written like this, which is the standard form, general form, trinomial form, or like this, which is the vertex form. Those are pretty easy. But what happens when we have quadratic equations written like this? Well, those are today's exercises, so let's find out. So before we get started, the first thing I want to address is what the parabola should look like. And most of you already know this, but the parabola should look like this, or it should look like that, right? What it should not look like when you draw it is like this, because that is an absolute value graph, all right? And it should also not look like that. I really hope mine don't look like that, but we'll see what happens. So what would I need to graph this parabola? Well, the first thing I would need is the vertex and the x-intercepts, if any. Sometimes we're going to find out that we're going to have one x-intercept, two x-intercepts, or no x-intercepts, and we're actually going to see examples of all three of them today. So what exactly is the vertex, and how do we find out? Well, the vertex is going to be the highest point of the graph if the parabola opens down, or the lowest point of the graph if the parabola opens up. And we write it as HK. And this is still an x coordinate and a y coordinate, but it's so special that we give it its own name. So if I have the vertex form, I mean, it's in the name, it's the vertex form, so it's already giving you the vertex. All you need to do is look what number is here and what number is here, okay? Now this, I'm going to include this here because sometimes you would have minus a number, so that would be a negative k. And the place I find most confusion on my students is the h, because they forget that this is actually a negative, which means that when you're looking for the h, you only take into account this number right there. So if this was like x minus 3 squared, you're only going to take into account the 3. The h would actually be the 3, not negative 3, and vice versa. If you have x plus 3 squared, then you have to think about this as x minus negative 3, so the h would actually be negative 3. And I just wanted to clarify that for those of you who find this a little bit confusing. All right, so what happens when the equation that you have is actually written in the standard form? Well, you have two formulas that you can memorize if you want to. I am not a huge advocate of memorizing formulas, but these two are pretty important. So the first one would be to find h. All you do is have negative b over 2a. So you substitute b here and you substitute a here. Bam, that's going to give you the h. And to find k, there are two ways of doing it. You can either substitute on x right here, whatever value you find here, you can substitute it on x, or you can use the formula 4ac minus b squared over 4a. And I know that sounds like a lot, but sometimes there are exercises where the x is kind of a weird number and you really don't want to substitute it back into the equation, and you're going to be better off using this, and we're actually going to see an example about that today. Alright, so let's get started with our first exercise. We have that y equals 5x times x minus 4 plus 5x squared. Well, the first thing I see is that I can FOIL these two, because my main goal is going to be to make them look like either the standard form or the vertex form, right? That's what you always want to do so that you can find the vertex and the x-intercepts a lot faster. Alright, so let's start with that. Let's FOIL right here. We know that 5x times x is going to be 5x squared, and 5x times negative 4 is going to be minus 20x, and plus 5x squared. We right away notice that we have two like terms, which are 5x squared and 5x squared. So that's going to be 10x squared minus 20x. Now notice that this is the closest that we're going to get to the standard form, because we don't have a c. Technically, right? What we really have is that this is plus 0, right? So my a is going to be 10. My, let me do this, it doesn't look like a fraction. My negative 20, right? That negative has to be included, is going to be my b, and 0 is going to be my c. okay, which I don't really need C to find the vertex, but it's good to know that it's there anyway. So in order to find the vertex, we said that we have to find the h first, which is the x coordinate for it. And the x coordinate, or the h, we're going to find it by making h equals to negative b over 2a. So that would mean that negative b, because b is negative, this is actually going to be minus or negative 20, which is positive 20, right? So I'm going to write it like that anyway so you can see it, but it's actually positive 20. It's going to be times 2 over 10. So that's going to be positive 20 over positive 20, and that's going to be equal to 1. That means that our h is 1. All right? Now, what will be our k? Well, like I said, you can do the 4ac minus b squared over 2a, but in this case, I don't think that's necessary, because if our h is 1, it would be so much easier to just substitute it here, right? We would have 10, just going to do here 10 times 1 squared minus 20 times 1. That is just going to be 10 minus 20, which is equal to negative 10. So that means that my vertex then is going to be 1, negative 10. All right? Well, what about our x-intercepts? Well, to find the x-intercepts, we're just going to go back to the original equation that we found out as the standard form. And what we're going to do is we're going to factor it. Okay? So, in this case, the first thing I see is that 10 is a common factor of 10 and 20. It's actually the greatest common factor, and so is x. So I am going to bring the 10x out of that equation. So it's going to be 10x, and that's going to be multiplied times x minus 2, which is going to be equal to y. Now, we explained in our previous video on finding the x-intercepts and y-intercepts that the way that you find the x-intercept is when y equals to 0. Right? So that's what we're going to do. We're going to make this equal to 0. It's going to be equal to 10x times x minus 2. Now, when is that ever going to be 0? And this is why we factor it, right? Because we know that the only time that multiplication going to be 0 is when one or both are 0. Right? So when is this ever going to be 0? When 10x equals to 0 and when x minus 2 equals to 0. And or when x minus 2 equals to 0. So all I gotta do here is divide by 10. 0 over 10, 10 is still 0. So x is gonna be equal to 0. And x minus 2, I just add the 2 on both sides. X is gonna be equal to positive 2. So my x-intercept, some people like to write it just like that, like x equal to 0 and x equal to 2. I don't like to write it that way because eventually you're gonna be talking about asymptotes, like vertical asymptotes, and that's how you write them, and you can get a little bit confused. So I just rather write it as the coordinate, okay? So the x-intercepts would be 0, 0, which is the origin, and 2, 0. All right? All right, so on this exercise, we're actually lucky because the way that they wrote it is already factored pretty much, right? Almost. So let's factor it a little bit more. And in this case, so instead of finding the vertex first, we're actually going to end up finding the x-intercept first, but that's actually going to work in our favor, and we're going to see why. So we know here in this factor that there's still a common factor, which is 2, right? So I'm going to bring the 2 out, and this is going to be x minus 2. This is going to be x plus 2. Right? So because it's already factored out, we can find the x-intercepts very easily whenever x minus 2 equals to 0 or when x plus 2 equals to 0. We know that that's going to be our x-intercept, so x is going to be equal to 2 and x is going to be equal to negative 2. Right? So these are going to be my x-intercept is going to be 2, 0 and negative 2, 0. Right? So how do I find the vertex? Well, I can do it 2 ways. I can either go back and FOIL the whole thing, right, and find the standard form, pretty much the same thing that we did in the previous exercise, or we can do it a second way, which is kind of a hack I'm going to teach you today, and that is finding the midpoint between the 2 x-intercepts. And why is that? Well, let's graph it real quick. We're going to graph them all at the end, but let me do a very quick representation of what it would look like. This would be the graph, right? Let's suppose we have 2 here and -2 here, right? These are my two x-intercepts, right? Well, we know that the parabola is going to open up because this is a positive, right? So it's going to open like that. Okay? So what we need to look out for here is the fact that any points that are, whether are these 2 points right here, or these 2 points right here, or these 2 points right here, it doesn't matter. They're always going to be equidistant from the center, because the center is actually what we call an axis of symmetry. All right, the vertex, or the h of the vertex, will act as an axis of symmetry for the entire parabola. So as long as they have the same y, right? So these are not super straight lines, but they should be straight, okay? So as long as they share the same y, which in this case they both do, the vertex is going to be exactly in the middle between them, okay? So what would be the midpoint between 2 and -2? It would be 0, okay? So we know that the vertex is going to be 0 on x. That doesn't mean it's going to be 0 on y. I don't know what the y is. I have to find out. So I am going to find out k by substituting the 0 on x. All right? Let me erase that. All right. So we have 2, the y, or the k, is going to be equal to 2 times 0 minus 2 times 0 plus 2, and that is going to be 2 times -2 times 2, that's my k, all right, and that's going to be 2 times -2 times 2, that's going to be equal to -8, which means that my vertex, then, this is going to be -8, my vertex is going to be at 0, -8. That's it. All right, so I have a pretty good one for you here. And the reason why I think this is a pretty good one is because it doesn't even look like a quadratic equation, right? But it is. It is. And the reason is because we actually have a square root on that side. So the first step is going to be to square both sides, which is going to give me an x squared, okay? And then we can keep going from there. So let's get started. So the first thing I do is square both sides. Okay, this is going to eliminate the square root, and I'm going to have that x squared is going to be equal to y plus 12 over 3. Okay, the second thing I do is just multiply by 3 on both sides. So I multiply by 3, and this is going to be 3x squared is going to be equal to y plus 12. And what I want to do ultimately is solve for y, right? So I can leave y by itself. And so I'm going to bring the 12 to the other side. So I'm going to have that 3x squared minus 12 is going to be equal to y. Or another way to rewrite it would just be y equals, right? So I'm going to rewrite it like that. So it's easier for us. It's easier to visualize that way. Okay, so now that I have that, I can do two things here. I can either just go ahead and find the vertex for it, right? Because we have our A, which is 3, and we have our B, which is 0. Okay, we know that B is actually going to be 0 because this is the same thing. I'm going to rewrite it here. This is 3x squared plus 0x plus, or minus, sorry, minus 12. Okay, so this is going to be our A, this is going to be B, and this is going to be C. So I can either do that, or I would prefer using the technique that I used in the previous exercise and actually factor first so I can find the x-intercepts, and I'll just find the midpoint between them. Okay? It's up to you. There's no right or wrong way to solve it. You do what works best for you. Okay? Always. All right. So I'm going to go ahead and factor it. So I know that 3 is a common factor, is the greatest common factor between 3 and -12. So I'm just going to bring the 3 out, and this is going to be x squared minus 4. And haha, we have a difference of squares right here. That gets me excited. So I know that this is going to factor as x plus 2 and x minus 2. So, right? So automatically I know, and by the way, I'm not sure if you guys would have this question or not, but I want to address it real quick. A lot of students have asked me in the past, well, what do I do with the 3? You don't do anything with the 3 because 3 is never going to be 0. So we cannot consider it as, you know, part of the process to find the x-intercepts. Okay, I just want to make that clear. So we ignore the 3, and then as long as it's being multiplied, okay? If you're adding it, then there's a totally different story, totally different type of problem. But in this case, we're gonna have x plus 2 equals to 0, which would be x equals to negative 2. And we're gonna have x minus 2 equals to 0, which would be x equals to positive 2. So just like the previous exercise, it's just coincidence. The x-intercepts are gonna be at negative 2, 0, and 2, 0. Okay? And again, I can use the same trick, especially it's way easier when you see it like that. I think that should be second nature for you, right? That you can just say, hey, you know what? I know the midpoint is 0, so let's just go ahead and do that instead of trying to just go back and rearrange the whole thing and try to, you know, do the negative b over 2a, mainly because also it's another formula that you have to memorize, right? And I am not an advocate for memorizing formulas because they will betray you. I promise. When you're in that time crush in the exam, they will betray you and you will put a negative where it doesn't belong or something like that. Okay, so it is way more important for me that you understand what you're doing and what the graph is supposed to look like than to try to remember like negative b over 2a and all that kind of stuff. Now, if that is the way that you understand math and if that's the way that works for you, go ahead. Kudos to you. My memory is awful. So if that's how it works for you and you have photographic memory, God bless you. That's awesome. But if not, it is way more important to me that you understand what you're doing. Okay, so the vertex, we know that it's going to be 0 on x or on the h, right? So we're just going to substitute for the x here so that we find out what the k is. And I'm not even going to erase anything because this is pretty quick. So this is going to be 3 times 0 squared minus 12, which means it's equal to 12, negative 12. All right, so the vertex then is going to be 0, negative 12. And that's it. All right, so this next exercise can be a little bit tricky for some of you because it looks like a difference of squares, but it is not, right? When you see it, the first thing you notice is that x is a square and 9 is a square. Bam, let's square root it. Can't do that, unfortunately. All right, no student of mine ever does that. Okay, you're better than that. So, what are we going to do then? How are we going to find the vertex? Well, we're going to find the vertex just fine. We can just do the, for h, we can just do the negative b over 2a. That's simple enough. So we're going to do b, which is, we know, just like the previous exercise or the previous before that one, I don't remember. The b is going to be 0 because this is x squared plus 0x plus 9. So this is going to be negative times 0 over 2 times 1. So this is going to be just 0 over 2, which is 0. So we know that the vertex is going to be 0 on x. Well, let's find out what it's going to be on y. Simple enough. It's just 0 squared plus 9, which is just 9. All right? I don't think we need to write that down. All right. So now, where are going to be the x-intercepts? Does it have any x-intercepts? Well, the answer is no. There's no x-intercepts. All right? Because that graph is actually going to look like, and we're going to see it at the end, that graph is actually going to look like that. Hopefully better than that. But that's pretty much what it's going to look like, and I'm going to show you why. This right here, so let's try to solve it. Right? Let's find out what x would be if y was 0. So 0 equals x squared plus 9. The only thing that we can do here to solve for x would be to subtract 9 to the other side. So negative 9 would be equal to x squared. And then to solve for x, we would have to square root both sides. So we would have the square root of negative 9 equals to x. Well, we know that the square root of a negative number doesn't exist. It's an imaginary number. Okay? So we can't use that. So actually, it's not going to have any x-intercepts. Now, how are we going to graph it? I'm going to show you at the end. Alright, so this next exercise is not super far away from the standard form, but there's one little thing that I want you guys to notice here, and it's that we have a negative outside the parentheses here, which means that you cannot forget to distribute that negative inside of that parentheses. Okay, so when we rewrite this, we're going to rewrite it as 3x squared minus 4x plus 8. I see lots of my students doing this -4 and then -8. Don't do that. Remember that the negative has to be distributed to the 8 as well. Don't leave it hanging, because otherwise it's going to get sad. Okay? Alright, so what are we going to do first? Are we going to find the vertex first, or are we going to find the x-intercept? Well, it's up to you. I am going to do the vertex first because I can't really factor this, right? So what I'm going to do is, let's do h equals -b over 2a, right? Which is going to be -4, right? So it's going to be -4 times 2, or over 2, sorry, times 3, and that's going to be equal to 4 over 6, which is 2/3. Okay, so the h is actually going to be 2/3. Now, this is one of the few times that I would actually use the formula for k to solve for k instead of just substituting the 2/3 inside of the function or the equation, because it'll probably be just easier, especially if you're not really comfortable with fractions or you really don't like them. You can avoid them by doing that. So k would be equal to 4ac minus b squared over 4a. I think I said 2a in one of the previous examples. I apologize. It's 4a. All right. So let's do it. So that would be 4 times 3 times 8 minus -4 squared, right? So that -4 is going to go squared, and all of that is going to be divided by 4 times 3, okay? Because we know this is our A, this is our B, and this is going to be our C. All right, so let's do that math real quick. It's going to be 96 minus, now it's still going to be minus because the -4 is going to be squared, so -4 times -4 is positive 16, but that's going to be minus 16, so minus positive 16. All right, and that's going to be divided by 12. Well, that is going to be equal to 80 over 12, which reduces into 20 over 3, which is the same thing as 6 2/3. That is going to be my k. My k is going to be 6 2/3. And the reason why I'm leaving it like that, I've mentioned in previous videos that I don't like using mixed fractions like that. It's because it looks like a multiplication sometimes. It could look like a multiplication to some people, at least it does to me. So I try to avoid them, but in this case it'll be much easier, or put it on decimal point. This would just be 6.6 repeating, right? To locate it in the graph. Alright, so now let's find out the x-intercept. Well, if I were to solve it using the quadratic function, which would be the most appropriate thing for a problem like this where you don't really know if it factors or it doesn't factor, right? You would just do x equals, and this is one of the few that I actually recommend that you should really memorize because it's gonna come up. Usually it's probably gonna be given to you in an exam, but if they don't, you should really memorize it. Alright, -b plus minus the square root of b squared minus 4ac, all of that divided by 2a. That is the quadratic formula. If I substitute, this is a, b, c, I substitute here, this would be -4 again, plus or minus this square root, and this is going to be -4 squared minus 4 times 3 times 8. All of that divided by 2 times 3. Now, this is what we call the discriminant. I'm not sure if you've learned this yet, but if not, this is the discriminant, which means that if this number becomes negative, then this problem has no solution, because you cannot have the square root of a negative number. Okay, so let's find out. Alright, so we're actually going to have 16 minus 96, which is -80. So, and if we have negative 80, then this cannot be possible, therefore there is no x-intercept. And like I said, just like the previous problem, I am going to show you how to graph them then. If you don't have an x-intercept, I'm going to show you how to graph them at the end. Alright, and last but not least, we have this pretty simple exercise, but I'm going to show you what it has different than all of the other exercises that we've done so far. Well, let's get started. We do the multiplication first, because we can't do anything in the parentheses. So 4x times x is going to be 4x squared. 4x times negative 3 is going to be negative 12x. And this is just going to be plus 9. So, bam, right away, it actually looks like standard form. So we're in luck today. All right, so there's two ways that we can do this. We can either factor it. If you're more comfortable with factoring, you can go ahead and do that. You can do the quadratic equation if you want to. Unfortunately, 4, negative 12, and 9 don't have any common factors, so I can't really bring a factor out and make it a simpler equation. But if you see that ever, please do it. Always do that so you can have smaller numbers. It's always easier to work with. But in this case, we don't, so I'm just going to have to factor the regular way, which would be that I have to multiply 4 times 9, all right, which is 36. And I'm going to find the two factors of 36 that would give me negative 12. It's kind of erroneous assumption that if you have this negative and this positive, then you will not have any factors in common. That is not true. In this case, remember that two negatives, right, when you multiply two negatives, they will also give you a positive. So if I multiply negative 6 times negative 6, right, that's going to give me positive 36, but it's also, when I add them, it's also going to give me negative 12. So be very careful with that. Okay, so what I'm going to do is I'm going to rewrite negative 12x as negative 6 minus 6x. All right, so it's going to be 4x squared minus 6x minus 6x plus 9. All right, and what I'm going to do is I'm going to pack these guys together, and I'm going to find the greatest common factor. The greatest common factor between these two is going to be 2x. So I bring it out, and that's going to leave me with 2x minus 3. And this, because this has a negative here, I have to start with a negative first, okay? So the common factor between negative 6x and 9 is going to be negative 3. So I bring out the negative 3 and times 2x minus 3. And then what we're going to do is we're going to group together the ones that are outside, and we're going to put together the ones that are inside, right? So 2x minus 3 times 2x minus 3. Okay, and that is just coincidence, or I don't want to say coincidence, but specific to this exercise. That's not always going to be the case. Okay, sometimes this is going to be like x plus 6 or whatever. It's going to be totally different. But these two have to be the same in order for you to factor this correctly. Okay, so because this is 2x minus 3 times 2x minus 3, this is the same thing as me saying 2x minus 3 squared. So now in order for us to find the x-intercept, this is going to be really easy because we're only going to have one x-intercept, okay? Because either 2x minus 3 is 0 or 2x minus 3 is 0, right? So when 2x minus 3 equals to 0, we pass the 3 to the other side. We have that 2x equals to 3. If we divide by 2, then we have that x equals to 3 halves, or 1 and 1/2, which is 1.5. Okay, that is going to be the x-intercept. Okay, so the x-intercept is going to be at the point 1.50. Okay, now we only have one. So if we only have 1 point, think about what that would do for the graph, or what the graph would actually look like. Well, if there's only 1 point touching the x-intercept, that means that that point is also the vertex. So my h is going to be 1.5 and my k is going to be 0. Bam, done. Now let's go ahead and graph them. All right, so let's get to the graphing part. I am actually just going to be graphing 3 at a time, so otherwise it was going to be too crowded and probably would confuse you more than it would help you. So, all right. So let's start with the first one. We know that a vertex is going to be at 1, negative 10. So that's the first thing I'm going to do. So I'm going to look for 1, negative 10, and that's going to be right here. And then I know that the x-intercepts are going to be at 0, 0, and 2, 0, which means that it's going to be here at the origin, and it's also going to be at 2, 0 right there. So remember I mentioned at the very beginning that you don't want to like just do straight lines, right? Because otherwise that would be a absolute value graph, right? So you want to make it a little curvy. So you want to go ahead and draw it kind of like that. And it should get straighter as you go up, but it should never go totally straight up, because that's just not how parabolas behave. They actually keep expanding, 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 expanding forever, ever so slightly, but they keep expanding forever. Okay, so I'm not going to keep going all the way up. I'm just going to graph this version right here. Okay, so that would be the first one. All right, so let's do the second one. We know that the vertex is going to be at 0, negative 8, which means it's going to be on the y-axis. So it's going to be right here. This is going to be the vertex of that one. X-intercept is going to be a negative 2, 0, and a 2, 0. So we're going to have one here at negative 2, 0, and one here at 2, 0. So this one's actually going to be a bit wider, so it's probably going to be easier to draw. So like that. They kind of look the same. And then for the last one, we have that the vertex is at 0, 9, so it's actually going to be like all the way up here, right, between the 8 and the 9, because I make these double so we could fit everything. But we saw the x-intercepts are none, because it actually opens up, which means that it's never going to pass through the x-axis. So how do we graph it then? All we do is pretty much how we learn to graph linear equations. It would be just find values of x that are before the vertex, and then values of x that are after the vertex. So let's start with just negative 1, right? So let's do negative 1, negative 2, and then we're going to do 1 and 2. Okay, so let's substitute for negative 1. Negative 1 squared is negative 1 times negative 1, which is 1, plus 9 is just going to be 10. And then if I do negative 2, it's going to be negative 2 squared, which is 4, positive 4, plus 9 is going to be 13. Okay, and 1 should also be 10, and 2 should also be 13. Now, not because they're negative 1 and 1, but because they're equidistant from the vertex. Okay, negative 1 is one space left from the 0, and 1 is one space right from the 0. Okay, so even if we do the math, 1 squared is 1, plus 9 is just 10, and same thing for the 2. 2 squared is 4, plus 9 is 13. All right, so negative 110 and positive 110, and then we're going to have negative 213, so that's negative 213 and positive 213. And then this one is actually very nice, already pretty much drawn for me that way. I missed. It's pretty much drawn for you when it's that way. There you go. So now let's do the next 3. So in this 3, the first one that we have is that weird one that we had x, right? That we didn't even know if it was going to be a quadratic equation, but it is. And we found out that the vertex of that function or that graph is going to be at 0, negative 12. So we're just going to find it right here, 0, negative 12. And the x-intercepts are going to go to negative 2, 0, and 2, 0. So it's going to be right here and right here. Again, this is going to be pretty broad. Right there. I missed again. I guess the angle is just kind of weird here, but anyway, so it's kind of like that. Just try to make it a little curvy. It doesn't really matter if it's not perfect, obviously. It's just need to be a little curvy. You're not a machine. It's fine. Neither am I. All right, so what about the second one? So the second one, I actually wrote both ways just so that you can choose which one is better for you. So you can either write it as a fraction or you can write it as a decimal. To me, it's a little bit easier to see it as a decimal, especially when the number is greater than 1. So I left this one as 2/3, which is actually 0.6 repeating. So it is going to be somewhere around here. And again, we don't have to be super perfect about it, but the y, though, it's going to go to 6.6 repeating. So it's actually going to be like here, kind of, but then it goes up kind of close to 7, but not quite. Okay, so it's going to be somewhere in there. It's fine. And then we said again that there's no, for this one, there's no x-intercepts either because it's going to be opening up. So what do? Same thing that we did on the previous exercise. So we're going to find values for x and we're going to find values of y's. Now careful, because this time I cannot just do like -1 and -2 and then add those values to 1 and 2 because this isn't 0, right? Which means that this is not in the middle. I can't, the distance between this and -1 is not going to be the same distance as this from this to 1, okay? So I have to be very careful about that. I will just solve them mathematically instead. All right, so let's just do 0 and a -1. All right, and then we can do 1 and 2. All right, so if we solve for this, it would be useful to have the equation that you simplified it into, but in this case, if you don't have it, that's fine. We'll just substitute, so it'll be 3 zeros squared minus 4 times 0 minus 8. So that means this is going to be 0, this is going to be 0, but this is minus -8, which means that this is going to be positive 8. Okay, so you have to be very careful with that. And then for -1, we do the same thing. I'm just going to do it down here.
Y is going to be equal to 3 times -1 squared minus 4 times, minus 4 times -1 minus 8. All right?
And that is going to be 3, because -1 squared is just 1. So this is going to be 3 minus -4 minus 8. So you can either distribute this negative twice, or you can just do -4 minus 8, which is -12. So this is going to be 3 minus -12, which is going to be 3 plus 12, which is 15. All right, so that's going to be 15 right there. So we are going to have 1, so y is going to be equal to 3 times 1 squared minus 4 times, I do the same thing twice.
There we go. Times 1 minus 8.
All right, and that would be 3 times 1 again, that's just a 3, minus, and that's going to be 4 minus 8, which is -4, so it's going to be minus -4, so it's plus 4, which is 7. All right, so that's going to be 1, 7. And when we do 2, it's going to be
3 times y equals 3 times 2 squared minus 4 times 2 minus 8.
Here we go. And that would be 2 squared is 4, so this is going to be 3 times 4 minus, that would be 8 minus 8, which is just 0. All right, so this is just going to be 12. All right, so let's grab it. So we have 0, 8. So that's going to be 0, 8 right here. We're going to have -1, 15. So it's going to be -1, and it's going to go all the way up here, 15. We're going to have 1, 7. So we do 1 and then 7, which is right there. Probably not the best choice because these two are so close, but it will guide you to where it's supposed to go. So I guess it's not horribly bad. And then 2, 12. So we have 2, and this is going to go all the way up to 12. So let's try to, yeah, I hit it. Oh, it's that side that gives me difficulty. Let's see. Kind of. It's okay. I'm like the graph I showed you at the beginning. That I said I wouldn't do. Alright, but anyway, so yeah, it would look something like that. And last but not least, we have the vertex at 1.50, right? Again, you can choose to write it as 3/2 if that's your choice, if that's your preference, that's cool too. But it would be 1.50 today. So this is going to be 1.50 right here. And the x-intercept is also going to be 1.50, which means that we're going to have to use this part so that we can calculate the rest of them, right? Because it's not just when you don't have a x-intercept, but also when you only have one, which is the vertex. So you have to find out what the other ones are. So now, 1.5, we could use 1 and 2, which are equidistant from 1.5, and that way we know that whatever we get for 1 is the same thing for 2, right? So let's try that. So if we do 1, this would be 4 times 1 times 1 minus 3 plus 9. That's just going to be 4 times 1 minus 3 is -2 plus 9. Plus 9, which is going to be -8 plus 9, which is 1. So this would be 1, 1. So this would actually go right here. All right? And if we do 2, we should get the same thing. Okay, so if we do 2, too lazy to erase it. And then, dang it. All right, so this would be 8 out here. 2 minus 3 is negative 1. And so this would be 8 times negative 1 is negative 8. Plus 9 is also 1. All right? So, and then we can keep doing that for the rest of them, right? So we can do 0. We can do 3, right? 0 and 3 should have the same y value, right? So, 0. If we make a 0, that'll be the easiest. 4 times 0 is just 0. It makes the whole thing 0, right? So it's just going to be 9. All right? So this is going to be 9. And if we solve it for 3, it should be the same thing. Because if we make this 3, this is going to be 3 minus 3, which is 0. This makes the whole thing 0, which is going to be 9. All right? So 0, 9. 0, 9 right here. And 3, 9. Right there. And that should be enough. Oh, I didn't write the 2. 2, 1. Sorry, I forgot the 2. So, now we can do it. And that is it for today. If you found this video helpful, go ahead and give it a thumbs up. And don't forget to subscribe to my channel so you can see when I post new videos. If you have any questions or any suggestions of topics that you want me to talk about, go ahead and email me at isabelexplains@gmail.com, or you can just leave it in the comments down below. So I will see you guys next time.